Oh, hello, everyone. Today's topic is about magnesium deficiency and how it leads to insulin resistance. And if insulin resistance is not managed, it can lead to type 2 diabetes. So magnesium is a vital mineral that plays a key role in over 300 biochemical reactions in the body. It is an essential nutrient or an essential mineral. An essential meaning we must get it from our diet. The body cannot make it on its own. Well, what happens when magnesium intake is insufficient? Now, when we don't have enough of it in our body, the body compensates by drawing it from either our bones or our muscles. If it resorts to drawing from our bones, we end up with low bone density, which can lead to a condition called osteoporosis. If it resorts to drawing it from our muscles, it can result in muscle weakness, cramps, or fatigue. So it's very important to have enough of it. We're going to look at a couple graphs displaying how we're doing from the population perspective in terms of magnesium deficiency and insulin resistance. So when it comes to magnesium deficiency in 1930, we were looking at less than 10% of the population suffering from magnesium deficiency. Fast forward to 2020, we're looking at more than 60% of the population with magnesium deficiency. Insulin resistance, on the other hand, in 1930, we were less than 4% of the population with insulin resistance syndrome. And fast forward to 2020, we moved all the way up to more than 35% with insulin resistance. Now, some of the key functions of magnesium in the body, as I stated earlier, it is involved in over 300 biochemical reactions. But to just name a few key functions, we find it heavily involved in mitochondria health and energy production, muscle and nerve function, bone health, supporting calcium metabolism in particular, heart function, blood pressure control and blood sugar control, DNA synthesis and repair, and obviously in oxidative stress and anti-inflammatory effect. Now, some of the signs that we may see in our body that can help us identify magnesium deficiency: fatigue and muscle weakness and cramps, oxidative stress, frequent headaches and migraines, anxiety and depression, increased risk of blood clots, insulin resistant, obviously, constipation, and low bone density and osteoporosis risk. So some of the factors that deplete magnesium in the body. We know that alcohol and caffeine inhibit the absorption of magnesium in the small intestines. We also know that certain medications such as diuretics, antibiotics, and PPIs can reduce magnesium levels over time. Now, as I stated earlier in the beginning of this presentation, this is an essential mineral. And the daily recommended allowance for men is measured to be 420 milligrams per day. As for women, it is 320 milligrams per day. These numbers vary from one person to another, depending on their levels of activities, their lifestyle, and their diet. Now, it is becoming more difficult to achieve magnesium efficiency these days. And what I have here is a sample of a daily intake for a 42-year-old female. And if you add up her breakfast, lunch, snack, and dinner, her magnesium intake comes up to be 240. Now, this is already below RDA. But if you factor in the fact that we don't absorb all 100% of the magnesium intake, at best, we absorb 50% for healthy individuals. Now that leaves her with half of that quantity, 120 milligrams, which means she's running a deficit of 70% on a daily basis. Another case here, I have a 48-year-old male. His breakfast, lunch, dinner, in terms of magnesium, comes up to be 413 milligrams per day. But if you time that with the absorption rate of half of the quantity, or 50%, you come up short by 50%. Now, once again, this is all his meals are healthy, but yet again, he's falling short and not meeting his RDA on a daily basis. Now, all I want you to take from this slide is the absorption of magnesium depends on two things. One, enough hydrochloric acid that helps magnesium element or ions to be liberated from other nutrients so we can be ready for absorption. And two, absorption is hindered and delayed because phytates and oxalates and lectins that are found in vegetables and legumes tend to bind to magnesium and cause or create what's called complex insolubles. And because they're complex insolubles, it becomes impossible for the body to absorb them, and they end up excreted out via stool. This is where the connection with not enough magnesium in the cells causing insulin resistance. So this image here is very important to understand. So if you see here in blue, you have the glucose transporter under GLUT4. Now, because this GLUT is inside the cell and not on the top of the cell membrane, it makes this cell either a muscle cell or a fat cell. And because of that, it relies heavily on magnesium to stimulate what's called tyrosine kinase, which resides in the insulin receptor to cause a cascade of insulin signals to act on that glucose transporter 4 to move upstream into the cell membrane so we can intercept glucose and allows it in or facilitate its transport into the cell so we can generate ATPs. So when that process is hindered by magnesium deficiency, now the whole signaling mechanism gets delayed and the glucose is delayed moving up into the cell membrane to intercept glucose, which means glucose is going to travel and stay in the bloodstream longer than it should. That on its own causes the pancreas to produce more insulin, which leads eventually to insulin resistance. So let's talk about some supplements. There are two supplements that are known in the market today. One is magnesium glycinate or magnesium biglycinate. Now, it is called as such because the magnesium mineral binds into two glycinate or glycine amino acids, and they form a chelation. And a chelation is just a process of binding a mineral to amino acid. Anytime you have a mineral bind to amino acid, it's a chelation. And the reason why they do that is so that they can enhance its bioavailability or absorption. So this is why magnesium glycinate has a high absorption rate. And because of this chemical structure that allows it to be absorbed in the small intestine, but this time it will be absorbed as a peptide, although it's not a peptide, but because it has two amino acids, the peptide transporter in the small intestine treats it as such, and it gives us a much better chance at absorbing most of the supplements. So when you buy a supplement, look for magnesium biglycinate, fully chelated, and it is better if it has albumin. TRAAC means it has been chelated by a third-party vendor. So once again, it should be magnesium biglycinate, fully chelated on the bottom. That's how you know that This is magnesium. This magnesium has a high absorption rate. Now, there is another form called magnesium citrate, and the reason why I listed it here, because this is particularly helpful for those that suffer from constipation. And the reason why it helps constipation is because once it's in the intestine, it draws water in, because it acts as more or less as an osmosis solution. And that helps the water move into the intestines, and it facilitates and it relieves the person from constipation. So some of the food sources, I do have 2 sections here. You can either get them from meat products. On my left, you have sardines are high in magnesium. Mussels, oysters, shrimp, all of these are high in magnesium. As for plant-based, pumpkin seeds by far is the #1 go-to. If you can incorporate simply 1 ounce of pumpkin seeds can give you about 150 milligrams of magnesium. So this is an opportunity to add pumpkin seed to your breakfast. You'll benefit greatly, a great deal from its high content of magnesium. Now, I do have other things here, almonds, spinach, all of that. It has high amounts of magnesium. So if you want to modify your diet to make sure that you're incorporating some of these, it will be beneficial. So the biomarker or the lab work that you want to test, obviously, you don't want to just go ahead and start taking high quantities of supplements. You want to make sure you measure your magnesium RBC. And RBC means red blood cell, magnesium intracellular in the red blood cells. And the reason why I like this biomarker instead of the serum is because it's much more reliable. And the magnesium in the serum is subject to urination or filtration, which means it's inadequate and doesn't give us the full picture on how much of it is absorbed by the cell tissue. So magnesium, when you order your lab work or you go to your doctor, make sure that you order magnesium RBC for a much better accurate result. Some combination that you want to consider. You don't want to mix magnesium and calcium when taking supplements because they compete for absorption. You do want to make sure that you have enough vitamin D in your body because magnesium helps activate vitamin D, which improves calcium absorption. So this is very important to know. You don't want to mix zinc and magnesium because they compete for absorption. And you also don't want to mix iron with magnesium. If you are taking iron, you want to take magnesium at a different time. And that's about it. I do have references here where I get all this information from. And as always, if you have any questions, please drop them in the comment section. Thank you so much and goodbye.